All right, so these are going to involve drawing triangles, like we've been doing. Before we get started, if it's not on the unit circle, so it's not pi over 3, pi over 4, pi over 6, pi over 2, whatever, you have to do Pythagorean theorem. And for these, oftentimes you do use those little locker combination ones, so that you don't end up with weird square roots. So let's review them just off to the side, like in the corner here. What's one of those locker combinations? What's the one with the little numbers I told you to remember? 3, 4, 5 is one of them. Very good. Does anyone remember another one? 5, 12, 13. I will just go ahead and tell you the others. 7, 24, 25. And 8, 15, 17. Obviously, they go on forever. Numbers are infinite. Those are not the only ones that there are. Those are just the ones with small-ish numbers, because after that, they start getting kind of large. Those are the only ones I have memorized. Okay, so the first type of identity we're going to do are your sum and difference identities. They're called sum and difference because, well, what does sum and difference mean? Like, what do those words mean? Yeah, adding and subtracting. So do you see how it's sine of A plus B and sine of A minus B? Like you're adding and subtracting things. Okay, anyway, that's what that is. So when you look at this, this is not a negative angle. You will not rotate backwards. Your first angle is pi over 2 and your second angle is 2 pi over 3. That's the most common mistake here is people will rotate backwards. 100% get why that happens. But this minus just tells you which one of these formulas we're using. It's sine and it's subtraction. So we're going to use this one right here. Do you see where I'm getting that from? Okay. So first thing, let's list it out. It's going to be sine of A, which the first one's A. So it's going to be sine of pi over 2. And you don't have to memorize this. You just need to be able to read and follow along. Pick which one you're going to use and then follow along with it. Cosine of B. So that's going to be cosine of 2 pi over 3. Not negative 2 pi over 3. Again, that minus just tells you which formula to use. Minus, all right, and then what comes next? Cosine of, which one's A? Pi over 2, good. And then lastly, sine of 2 pi over 3. So you are going to need one little picture for pi over 2, which actually won't be a triangle, that'll be a circle, and one little picture for the 2 pi over 3. So just off to the side here, kind of small because I don't have a ton of room. Where is pi over 2? Using a word like up, down, left, right. Up, good. So what point is that? 0, 1, perfect. So that is your work. What quadrant is 2 pi over 3 in? Second, good. So your reference angle is pi over 3. What goes across from pi over 3? Square root of 3 over 2, good. And that means the other side is what? A half. Oh, good, but why is it negative? In the second quadrant, you went to the left. All right, so that is your work. Now we're just going to go fill these in. Sine of pi over 2. Sine is which one of these numbers? The 0 or the 1? 1, good, it's the y value. Cosine of 2 pi over 3. So here's your 2 pi over 3 picture. Cosine is which one of those? The negative a half, it's the x value. Good. Minus, all right, cosine of pi over 2 is 0. So this last part's going to be 0, but just for the sake of being thorough, sine of 2 pi over 3, sine is the y value, so square root of 3 over 2. But 0 times anything is 0, so this part's going to be gone. What's your final answer to the whole thing? Like if that goes away, negative a half is your final answer to all of it. That was weird because we ended up with a 0 in there, but we're going to try a couple more. All right. Do you see how that is 7 pi over 12? And this is kind of the point of these identities. All right. 7 pi over 12 is not on the unit circle. So what we're going to do is we're going to come up with 2 angles that we can add together that would equal 7/12. I want you to think about it. What 12ths plus what 12ths could equal, basically I'm asking you, what are some numbers that add up to 7? And why would, you guys got it on the first shot, why would 3/12 plus 4/12 be good? Like, why wouldn't you want to do 1/12 and 5/12, let's say? Or I guess 1 and 5 won't make 7 anyway, but 1/12 plus 6/12, like 1/12 is also not on the unit circle, but these are gonna reduce to be what? Pi over 4 plus pi over 3, good. You reduce the fraction. So you need to pick things that are on the unit circle. Like 5/12 is not on the unit circle. Like you need to pick things that are gonna work. So out of these formulas, which one do you want? Well, you want the one that says cosine and what? A plus B. So do you guys see how it's this one? If you can't pick the right formula, you're gonna be out for the whole thing, all right? So let's read along. It says cosine A. That's gonna be cosine of what for this one? Pi over 4, good. You got there. I don't want to put a parenthesis there, otherwise we'll have a gazillion parentheses. All right, so cosine pi over 4, and then read what comes next. Just like read along with it. Yeah. Cosine of pi over 3, and then keep reading what comes next. Minus sine pi over 4, and then sine pi over 3. Good. So you're going to need 2 pictures. These all need 2. You're adding and subtracting things together. So pi over 4 will look like this. I'm just going to draw it up. We've drawn it a million times at this point. And then pi over 3 will look like this. The one nice thing about this is everything's in quadrant 1, so it's all positive. And then you just use those triangles, that's like your work, to go and fill it in. So cosine of pi over 4 is going to give us what? This is your pi over 4 picture. Yep. Square root of 2 over 2. Cosine of pi over 3. This is your pi over 3 picture. Which one of these is cosine? Yeah, the 1/2. Good. Cosine is x. Minus sine of pi over 4. Square root of 2 over 2. And then what is sine of pi over 3? This is the picture you want to look at. Square root of 3 over 2. Now, that one is a little bit messier than the first one we looked at. But can you multiply small numbers together? I mean, you can. You're going to be all right. If you multiply the numerators and the denominators, look at this first one. That's going to give you square root of 2 over what? 4. Good. 2 times 2 is 4. So square root of 2 over 4 minus, now square root of 2 times square root of 3 would be square root of 6. 2 times 3 is 6 over, conveniently, 4. And they already have a common denominator. So you're just going to shove it all together. It's going to be square root of 2 minus square root of 6 all over 4. Which is a great answer. Don't discriminate. I mean, that's what it came out to. So that's what it is. Why don't we have to rationalize or do anything with the square roots? Like, why can we just leave that? Because where are the roots? Yeah, they're in the numerator. When do you have to rationalize? When it's in the denominator. I just wanted to bring that up. All right, but you're done. That's it. You can't because they're not like terms. So yeah, you're done. That's it. Isn't that nice? You just finished. I know the answer looks weird, but you know, get over it. All right, find cosine A minus B. So that just tells you like, hey, this is the formula we want. Cosine A minus B. If these things are all true. I'll get to that in a second. First, let's list this out. Now, all we have is A and B. You don't have pi over anything. So just write out the formula. It's cosine A, cosine B, plus sine A, sine B. And that's the nice thing about these because you don't have to memorize them. It's right there. Like, you don't have to memorize it. For today, we're just going to look off of this sheet here. Like when you do your activity, you can just take this paper with you. When you take your quiz, I have a little formula sheet for you. All right, so off to the side, everything is positive for these. So they're going to be in quadrant 1. These are not on the unit circle. All right, so it's not going to say pi over something. I just wrote A there. We're back to SOHCAHTOA, sine, cosine, tangent, opposite, adjacent, hypotenuse. It says tangent is 5 over 12. Tangent is what over what? Good. So 5 is the opposite, 12 is the adjacent. Without doing any work, what's the hypotenuse? 13. Perfect. And then you're going to do another one for B. Now this says cosecant. Cosecant is the reciprocal of sine. Nice. Sine is opposite over hypotenuse, so this is going to be over opposite. Good. So the 5 is the hypotenuse, 4 is the opposite. Without doing any work, what's the other side? 3. Good. Perfect. You got there. All right. That is your work. Now you're going to just answer the question. Cosine A. So here's A. Cosine would be what over what? Good. So that would be 12 over 13. Cosine of B would be 3 over 5. Sine of A. Now sine would be what over what? Good, perfect. Opposite over hypotenuse, so that'll be 5 over 13. And then sine of B, be 4/5. When you multiply fractions, you just multiply the top and multiply the bottom. So multiply these together. 12 times 3 be 36. 13 times 5, what is that, 65? I think that's 65. Times 5. Plus, and then what will this one give you? Yeah, 20 over 65. And oh my gosh, they have a common. Here, you gonna be okay? We'll do our break in a second. So you can just go ahead and add them together. So what will that give you? Just add the numerators. Yeah, what is that? 56 over 65. So make sure you have 2 pictures for every problem. That is your work, but you don't have to memorize the identities, which is nice. All right, so this next set of identities are your double angle identities. There's 3 different ones for cosine of double A, cosine of 2A. I just always use the first one for no other reason than it's the first one. It doesn't make a difference. They'll all come out to the same thing. All right. So the nice thing about how I chose to do this is I made it all parts like A, B, and C, and all parts go with the same picture. So you're only going to need to draw one triangle. So it says given sine of A is 3/5 and the angle is in quadrant 2. So go ahead and draw your triangle in quadrant 2 off to the side here. We're going to call it A. Again, not on the unit circle. It's not pi over something. We're just calling it A. And sine is what over what? It's opposite over hypotenuse. Good. So what's the other side? But it will be negative. Good, because we're in the second quadrant. So that's your work for all of these parts A, B, and C. So it says sine of 2A. So you're going to look at your formula right here, sine of 2A. It says 2. Okay, so 2. I'm just reading it off of that. Sine of A. So what is sine of A? Good, so 3/5. And actually, it also just says it right there. And then what comes after that? Just read, you have to be able to read along with the formula. It says 2 sine of A, and then it says cosine of A. So what is cosine using this little drawing that we did? Good, so that'll be negative 4/5. And then you just multiply that all together. Now I'm gonna make a suggestion because the 2 out front is what messes people up. Make it be 2 over 1. The denominator's a 1. And then you just multiply all the numerators, multiply all the denominators. Let's see what we get. 2 times 3. 6 times negative 4, negative 24. And then down here, 1 times 5 times 5 is 25. And that's it. Formulas are like you just plug in and get your answer. That's all you're doing. All right, cosine 2A. Again, there's 3 different versions. You can use whichever one you want. I'm going to just use the first one. Cosine of A squared. So write it as blank squared. Cosine is adjacent over hypotenuse. So that's negative 4/5. Now foreshadowing before I get there, when you square a negative number, it's gonna turn positive. Okay, good. What comes next in the formula? Just read along. Good, minus, and go ahead and put blank squared. Sine is 3/5, opposite over hypotenuse. All right, then we're just gonna sort that out. This will end up being positive. Just square the 4 and square the 25. What do you get? Yeah, the 16 over 25, good. Minus, and then this one will give you 9 over 25. And when you subtract, you get 7 over 25. All right, and then last one, we're gonna do the same thing, just using this formula. It says 2 tangent of A. And actually, I'm gonna go ahead and put the 2 over 1 right away. Because again, that, believe it or not, is the thing that messes people up the most. All right, we haven't done tangent of A yet. What would tangent of this angle be? Good, opposite over adjacent, that would be -3/4. And then just continue reading the formula. There's a great big fraction bar. And then it's 1 minus tangent squared. So write it out with a blank first. And we just said tangent is -3/4. All right, and then you have to, sift through all that. And I realize that looks awful, but you're just multiplying small numbers together. What do you get up top? Good, -6 over 4. Big fraction bar. This will be 1 minus. Now, again, when you square a negative, it's going to turn positive. So this will be 9/16. Now, there's a lot of ways you can go through this. Here's my suggestion, and I'm going to do a little bit of erasing. And if you want to do something different, you can. There's a lot of ways you can simplify this. I would just go ahead and make them all 16ths, like right away. How many 16ths is a 1? 16 16ths. And then I'm just going to erase it. Up here, how could I turn that into 16ths? I would multiply by what? 4. So 6 times 4 be -24 16ths. The reason I recommend doing that is all the 16ths will now cancel out. Okay, so watch, this is what's going to happen. They're all going to go away. So that's why I recommend that. So it comes out to -24 over, and then down there you've just got 16 minus 9, so 7. Good. Again, lots of other ways you could get through that. You can get a common denominator and put things together. I just kind of like make them all the same and then cancel them out. All right. Last type of identities. So we just did double angle. These are half angle identities. So do you see how they're all a half a over 2? All right. So this says sine of pi over 12. I hope your first reaction is, hey, that's not on the unit circle. But pi over 6 is on the unit circle. And do you see how that's half of pi over 6? All right. So I'm going to rewrite it as sine of pi over 6 over 2. Pi over 6 takes the place of a. Half of a 6th is a 12th. Did you all come with me on there? 6 times 2 is 12. I don't know. I don't get any feedback from you guys. So just keep blathering. So we're going to need to draw a picture for pi over 6. And again, I'm not going to narrate that because we've drawn that 4 million times at this point. It's your quote unquote work for pi over 6. And then you're just going to pick the correct formula and plug it in. Do you see how they all have a plus minus? I'm not trying to put you to sleep. Can you persevere for me? Do you see how they all have a plus minus? That's dependent on what quadrant you're in. What quadrant is this in? First. So they're all going to be positive. Okay. So this is sine. We're looking at this one right here. It's going to be the positive square root. Draw a big old square root. And then you just have to read. You just got to be able to read. 1 minus. And it says cosine of A. Which one of these is cosine? Square root of 3 over 2. Fraction bar 2. So again, I would do the same thing we did on the other one where we made them all 16ths. I would make them all halves. If you erase the 1, how can you rewrite it so that it's halves? 2 over 2. is 1. And the reason I recommend that is then they're gonna go away. That's the whole point. Like these 2's will all. Oh, no, wait, I lied to you. Sorry, it's just a 2. It's not a 1/2. Never mind, forget that. Yeah, I'm sorry. Forget that. Leave that in there. I'm sorry. I'm sorry. We still want it to be 2, but sorry, they won't cancel out. Yeah, actually, that's a good conversation. I caught that right when I went to cancel it out. It won't cancel because the 2 is not in the denominator. They would have to all be in the denominator. But these now have a common denominator, so we can put them together. It would be 2 minus square root of 3 all over 2. I just put it all together. And then that's over 2. If you divide something by 2 and then you divide by 2 again. So if you split something in half and then you split it in half again, you've now split it into what? Fourths. So basically you're multiplying 2 by 2 there. It's going to look like this. And then what is your square root of 4? Because you can't do anything with this. That's just a gigantic mess. But what's your square root of 4? Is 2. So it is going to look like this. Which again, don't discriminate against your answer. It's going to look like a mess because the formulas look like a mess. If the formula looks awful, it's going to look awful. That's just the way that's going to be. All right, now these ones, A, B, and C, I made them so you can just draw a picture once and then that's it, all right? And also I put it in quadrant 1, so everything is going to be positive. And we have to get through this, but I was trying to give you a break. All right, so it says sine is 5/13. Sine is opposite over hypotenuse. What's the other side without doing any work? 12, good. All right, I'm gonna have to move the paper up and down to see this, so you can just look at your paper. So the first one, sine. You're gonna draw square root of 1 minus what? You gotta read along with me here. 1 minus cosine. All right, so cosine for this picture would be what over what? What number over what number? Good, 12 over 13. And then that whole thing is over 2. So I'm going to erase the 1 and make it 13 over 13. Why would I do that? Like, how would that benefit me? Like, why would that be any better? Yeah, common denominator. 1 is anything over itself, all right? So if you put those together, that's going to be 1/13 and then over 2. So if you divide by 13 and then you divide by 2, you've divided by how much? Basically, what's 13 times 2 is what I'm asking. It's 26. And I hate to tell you this, but when you go to do your delta math, it will mark that wrong because it wants it completely simplified. You know how to do this though. What's the square root of 1? 1. And the square root of 26 is square root of 26. And then you do have to rationalize that. So what's your final answer? Yeah, there you go. Not hard, it just has a bunch of steps. Good news for this one, because look at the 2 formulas. What do you notice about these? Compare them. It's the exact same thing, but that has a plus. So what you're going to do is recopy this, but just put a plus in it. And it's going to turn out, you know, a lot the same. So it's going to look like that. So instead of subtracting like 13 minus 12, we got 1. Now you just want to add them together. So 13 plus 12, be 25/13 over 2, which would be 25/26. And it's nice that it's 25. What's your square root of 25? Yeah, good. So it ends up looking like that. And then to your final answer, 5 square root of 26 over 26. It'll mark it wrong if you don't simplify it the whole way, which is why I'm going over them. It's not hard, right? Like you just have to find the formula. All right, and then the last one, tangent. Again, it's positive because we're in the first quadrant. Do you see where I'm pointing here? Last one. All right. 1 minus cosine, a big old fraction bar. 1 minus, all right, cosine is still 12/13. That hasn't changed. Fraction bar, and then what goes on the bottom? Just read it for me. Like, look back at the formula. Good, so it'd be 1 plus 12/13. What am I gonna change both the ones to? 13/13. Actually, I think this one will turn out better because we will get something to cancel. So this would be 1/13, and this would be, oh, this is gonna turn out better. 25/13, because now the 13ths will cancel out. So what's that gonna come out to? Yeah, well, it's square root of 1/25. 1/5. Perfect. Square root of 1 is 1. People forget about that one, but the square root of 1 is 1. Square root of 25 is 5.